This is Salisbury Fire Department's training minutes.
Good day, David Haynes, training captain with the Salisbury Fire Department, here with today's training minute. We're going to be reviewing, as part of our hydraulics series of training minutes, the basic formula for calculating the required pump discharge pressure for our driver operators. So this formula can have a couple of variations depending on your fireground assignment. We'll talk about those. I've also seen different elements of this formula referred to differently, so if you see it referred to differently in a text and what you're familiar with, just use that. The first caveat is that as driver operators, this is a memory jog. So it's not a terrible idea to have this maybe on a cheat sheet in your gear. Most of the time we would be doing pressure calculations for pre-connected lines, and it's numbers we're used to dealing with or pressures we usually go right to. But occasionally, and it's going to come a time where we have to actually figure out the discharge pressure. And this formula helps us account for all of the different elements that we need to get to that proper pump discharge pressure. So, in referring to pump discharge pressure, with this formula, we're referring to one discharge, one single outlet. So in practical fireground terms here, with our special effects, we've got our pump panel here. As the driver operator, I account for all of these four elements, and that's going to get me the proper pump discharge pressure for any one individual discharge. Okay? And if I'm only flowing one discharge, then that individual line gauge and the master pump discharge gauge would be the same pressure. If I was flowing two different lines, two different attack lines of different length, different nozzle, whatever the case may be, then those two individual discharge gauges, one may have a higher pressure than the other. The discharge with the higher pressure would match the master pump discharge gauge, and the other discharge with the lower pressure, we would gate back to the correct pressure at its line gauge. Okay? So the first thing we'll look at here is the basic formula, and this is set up for attack engine. That may change based on your fireground assignment. So the very first element for the attack engine would be the nozzle pressure, NP. And then the other three elements, friction loss, devices, or head pressure. So just in dealing with the nozzle pressure, there's four numbers that we would typically plug in there. And those would be, if we had a solid stream hand line, 50 pounds. If we had a solid stream master stream, such as a portable monitor or a deck gun, it would be 80 pounds if they had a stack tip. If we had low pressure fog nozzles on our hand lines, that number will be 75. And any other fog nozzle, automatic nozzle, whether it's a hand line or master stream, we would flow at 100 pounds. So nozzle pressure for an attack engine, one of those four numbers, 50, 80, 75, or 100. If our fireground assignment changed, and we weren't an attack engine, but instead we were a supply or a relay engine, then instead of going from our pump to a nozzle, we would be going from our pump to another pump. In which case the NP would change, and instead of nozzle pressure, we would call it RP, or residual pressure. And in the case of going from pump to pump on the fireground, I want to give that other driver operator at the end a little bit of pressure to work with. So I would give them a residual pressure of 50 pounds in a supply or relay operation. And that may also change. On some occasions we do direct fill at a fill site. If we're a supply engine filling into a tanker, then that number would go from 50 to 35 pounds residual pressure. So a relay or a supply, 50 pounds residual pressure. If it's a direct fill at a fill site to a tanker, 35 pounds residual pressure. So there's the variation there. Other than that change, the rest of the formula would remain the same for our calculations. And the next element will be the friction loss, and this is the friction loss in our hose lines between the pump and from pump to nozzle. And there's two directions we'll go with that. Typically what we use, 2 o'clock in the morning, user-friendly math, fireground hydraulics. And this is going to be some variation of the hand method or the Q squared, user-friendly math on the fireground. If you're using attack lines, this is usually the 30 pounds per 100 foot of a tack line that we might have figured out. But it's user-friendly, easy to plug in math on the fire ground. The other direction that we could go with that would be using the coefficient method. And if we were doing that, it would be the CQ squared L method to calculate the friction loss using the coefficients. So theoretical hydraulics using coefficients, or fire ground hydraulics using the hand method or user-friendly math. Either direction you go, that gives you your friction loss, but you have to make sure when calculating your friction loss that you ensure you account for the flow, the size, and the length of the hose. The next piece of this puzzle is the devices that we would account for, and those devices include gated Ys, Siamese, or master stream nozzles that we may be flowing through. So fire ground hydraulics, user-friendly, 2 o'clock in the morning. We typically count 10 pounds per device, and that includes any device, gated Y, Siamese, nozzle that's on the master stream. Each of those devices in the line, we would count 10 pounds per device. Some people use the flow, and they will come up with a friction loss number or a device number based on the flow through the device. If they're flowing 350 gallons a minute or less, they count 0. If they're flowing 350 gallons a minute or more, they would give it 25 pounds for that device. So whichever method you use, whether you're using the 10 pounds per device or the accounting for the friction loss in the device based on flow, make sure you account for it and plug it in here under devices. The last element that we have here is the head pressure, and this is to account for us moving water up or moving water down. And it could go either direction, it could be plus or minus. If we're moving water downhill from the pump into a sub-level or a basement, then we can take off a little bit of pressure because we're not having to work as hard to move the water down. If we're moving water up in a building, we have to add a little bit of pressure to get the water up there. So inside a building, moving water up floors, we would count 5 pounds per floor, not counting the ground floor. If we were outside and we're pumping to a ladder pipe or an aerial to the nozzle at the top, then we would use 5 pounds for every 10 feet, or basically half the height. An example of this, if we're going to a 3rd floor of a building, not counting the ground floor, you would add 10 pounds, 5 for the 2nd floor, 5 for the 3rd floor. If we were going to an aerial, flowing water to the nozzle that was at 80 feet on the aerial, then we would count 40 pounds, basically half that height, 5 pounds for every 10 feet. And this would be added if we're going up. If we're going down from the pump, we would subtract that amount. So that's a basic look at the formula that we would use to acquire the proper pump discharge pressure. And that's today's training minute. Thank you.